Hi friends, welcome to our YouTube channel Naraj Academy. The main aim of this lecture is to discuss about the IS or ESE Electrical Engineering Prelims question paper in of 2021 in a very detailed manner. And if you like the content of our channel, then please do like, share and subscribe our YouTube channel and don't forget to press the bell icon button. So whenever we upload a new video, the direct notification comes to mobile. If any improvements needed in our lectures, then please do comment in the comment section. We will definitely include all those improvements in the coming lectures. So why to waste more time? So let's get started. So now we are going to solve the 11th question. See the question here. If Z1 is equal to 2 into e to the power of j pi by 4 and Z2 is equal to 8 into e to the power of j pi by 3, then what is the value of the Z1 by Z2 whole square? So what are the four options? Option C is the correct solution of this question. So let's solve this numerical. So this is the value of the Z1, which is 2 into e to the power of j pi by 4. So we can write 2 into angle of pi by 4, 2 angle of pi by 4. And similarly, Z2 is equal to 8 into e to the power of j pi by 3. Means we can write in terms of angle pi by 3. This means r into e to the power of j theta, we can write magnitude is r and the angle part is theta. So in this fashion I have written here. Now Z1 by Z2 whole square. So I keep the value of Z1 and Z2 and need to do the square. So now if you want to do the square, so you have to multiply with again same thing, which is 8 into angle pi by 3. So 8 is 64. So it is now 64. And now pi by 3 and pi by 3 you have to add. So whenever we are multiplying these two things, these magnitude parts are going to get multiplied, but the angle parts are going to get added. So therefore pi by 3 plus pi by 3, we can write pi by 3 into 2. So therefore 2 by 64, this is the magnitude part, 2 by 64, and this angle part, if this angle goes to the upper, it will become negative. So therefore pi by 4 minus 2 pi by 3. So 2 by 64 is 1 by 32, and pi by 4 minus 2 pi by 3 is minus 5 pi by 12. So therefore here this is r at an angle of theta. So theta is negative. So therefore r at an angle of theta is equal to r into e to the power of j theta. So therefore 1 by 32 into e to the power of minus j 5 by 12. So this is the correct solution of this question. So now we are going to solve the 12th question. See the question here. The simplified value of the integration of x square cos ax dx is. So we have to find what is the integration of the x square cos ax into dx. So what are the four options? Option A is the correct solution of this question. So let's solve this numerical. So this type of question we have already discussed. So integration of f into g is equal to f into integration of g minus f dash of double integration of g and plus f double dash of triple integration of g, and it goes on. So therefore here always plus minus plus minus plus minus like alternate one. So which value we have to take f and which function we have to take g, it is going to be based upon the ilet function. So ilet, so based on this principle we have to choose which value is f and the other value is g. So E is called as the inverse trigonometric functions, and L is logarithmic functions, and A is algebraic functions, and T is trigonometric functions, and E is exponential functions. So based on this we have to choose the value of f and g. So whichever the function which is going to come earlier, that we need to choose the value of the f, and the remaining thing we have to go for the g. So if you see carefully here, integration of x square cos ax, here x is a algebraic one, means x square is a algebraic one, where cos ax is a trigonometric. So therefore algebraic is going to come earlier than the trigonometric. So therefore we have to choose the f is the means algebraic one, and the remaining thing is trigonometric. See, whichever the function which is going to come earlier, that we need to choose as a f, and the remaining function we need to choose as g. So therefore here algebraic is going to come earlier than the trigonometric. So therefore we have to choose the value of the function f is algebraic and the remaining g is trigonometric. So here f is x square, and integration of gx means we have to do the integration of the cos ax, which is sin ax by a, and similarly minus minus, and f dash means we have to do the differentiation of this x square, which is 2x, and double integration of g means we have to do one integration. So now we have to go for the other integration of this one. So therefore this is minus cos x by a square, and now it's a plus, and f double dash means 2x. If you do the another derivative, it will become 2, and similarly here cos ax is sin ax by a, so a square into a, it will become a cube. So minus is minus. So integration of sin ax is cos ax, integration of cos ax is sin ax, by a also it will be there. So therefore now after solving this one we are going to get in this manner. So therefore now I am going to take 1 by a cube as a common, and then this is the equation which we are going to get. So this is the correct solution of this question. So now we are going to solve the 13th question. See the question here. A network has 8 branches and 4 independent loops. So how many nodes are there in the network? So the four options, option C is the correct solution of this question. Means 5 number of nodes are there in the network. So in the question they are given the number of branches are 8 and the number of independent loops is 4. So now we have to find what is the number of nodes. So option is 5. Let's solve this numerical. So in the question they are given the number of branches are 8 and the number of links is nothing but number of independent loops is equal to number of links, which is 4. And then we need to find what is the number of nodes which are present in the network. We need to figure out, means the value of n we need to figure out. So therefore here L indicates the number of links and B indicates the number of branches and n minus 1 is going to indicate the number of twigs. So therefore the total branches, the number of branches is equal to number of links plus the number of twigs. So therefore the total number of branches is equal to summation of the number of links and number of twigs. So but we need what is the value of the L. So therefore L, so I am writing in another fashion, which is basically equation L is equal to B minus of n minus 1. So here L is equal to B minus of n minus 1. So we know that L is equal to, so minus I am going to take it inside, so minus n plus 1. So I know the value of L, which is 4. I know the value of B, which is 8, minus n plus 1. So only one equation with only one unknown. So therefore after solving this, we are going to get n is equal to 5. So basically the total number of branches is equal to the summation of the number of links plus summation of the number of twigs. So number of twigs is n minus 1, which is n is the total number of nodes. Minus 1 is going to tell you about the number of twigs. So after rearranging, we are going to get the number of nodes is equal to 5 in this network. So now we are going to solve the 14th question. See the question here. 3 light bulbs are connected to a 9-volt battery as shown in the figure. So what are the values of the resistance of 20-watt bulb, 15-watt bulb and the 10-watt bulb respectively? So here there are 3 bulbs. One is 20-watt, 15-watt and 10-watt. They are connected to a 9-volt battery source. So here we need to find what is the resistance of the 20-watt bulb, 15-watt bulb and 10-watt bulb in this question. So what are the 4 options? Option A is the correct solution of this question. So let's solve this numerical. So this is a circuit which is given in the question. So here 20-watt bulb, 15-watt bulb and 10-watt bulb and there is a 9-volt source. So here we need to find what is the resistance of the 20-watt bulb, resistance of the 15-watt bulb and the resistance of the 10-watt bulb. So here I am going to replace all these bulb with some resistors. So let me assume this value is R1. And similarly this value is R2 and this is R3. So we need to find what is the value of R1, R2 and R3. And let me assume, so now I want to know what is the value of this current I1. So this is 15-watt bulb. So let me assume the current in this branch is I1. So therefore here I want to know what is the value of the resistor R1. So I know the value of the power. This resistor is going to have a power of 20 watt and the voltage across this resistor or bulb 20 watt is 9 volt. So therefore P is equal to V square by R. So P is 20 watt, V square is 9 whole square by the resistor is R1. So only one equation with only one unknown. So therefore R1 is equal to 4.05. So 4.05 ohm is the for the resistor R1. Now I want to know what is the value of the current I1. So therefore P is equal to V into I. So P is equal to 20 watt and the voltage across this resistor is 9 volt and the current is I1. So 9 into I1 is equal to 20. So now I want to know what is the current which is flowing in this resistor or 20 watt bulb, which is I1 is equal to 20 by 9. And similarly here I want to know what is the value of the current, total current I, which is here the total power consumed by the circuit is or 20 watt plus 15 watt plus 10 watt. So this such amount of power which is absorbed by all these 3 resistors means the same amount of power, the total power should be delivered by the source. So whatever the power which is delivered by the source is equal to the power absorbed by this resistor. So the total power which is delivered by the source is 20 plus 15 plus 10 is equal to total voltage into total current. So total voltage into total current. Then here 20 plus 15 plus 10 is 45 is equal to 9 into I. So therefore I is equal to 45 by 9 is equal to 5. So I is equal to 5 ampere. So I want to know what is the value of this I2. So therefore the incoming currents is I and the outgoing currents are I1 and I2. So therefore I is equal to I1 plus I2. So I is equal to I1 plus I2. I know the value of I and also I1 also I know, but only thing is I don't know is I2. So therefore I2 is equal to I minus I1. So the value of I is 5 ampere and the value of I1 is 20 by 9. So if you substitute, you are going to get 25 by 9. So the amount of current which is going through R2 and R3 is 25 by 9. So basically now what we are going to use, power is equal to I square into R. So power is 15 watt, I square is, here the current is I2 square into R2. So therefore power 15 is equal to I2 square into R2. So power absorbed by this bulb second is 15 watt, current is 25 by 9 whole square into R2. So we are going to get R2 is equal to 1.945. So therefore R2 is equal to 1.945. And similarly for the 10 watt bulb, the current in this 10 watt bulb is I2 and the power which is 10 watt. So I need to find what is the value of R3. So P is equal to I square R. Power is 10, current is I2 whole square into R3. So therefore 10 is equal to 25 by 9. The current is 25 by 9 whole square into R3. So now the value of R3 is 1.297. So therefore the value of R3 is 1.297 ohm. So this is the correct solution of this question. So now we are going to solve the 15th question. See the question here. So for the circuit in figure, the value of I1 and I4 are respectively. So here now we have to find what is the value of the current I1 and I4 in this circuit. So what are the four options? Option A, I1 is minus 7.5 ampere and I4 is 2.143 ampere. So let's solve this numerical. So this is a circuit which is given in the question, and the current here we need to find what is the value of the current I1 and the I4 we need to figure out. So if you see carefully here, the current I1 is nothing but in this branch, in this 2 ohm branch, the current is I1. And also here I4 means the current in this branch is I4. So therefore we are going to remove all these loops. So therefore the diagram will be visible simply. So therefore we can do the analysis in an easy manner. So I am going to remove all this one because the current I1 is the which is flowing in the 2 ohm, and also in this branch 2 ohm the current flowing is I4, and this direction is I0. So now we have to find what is the value of the I1 and I4. This is a practical current source. So this practical current source I am going to convert into a practical voltage source. So at the arrow we have to keep a positive and the tail we have to keep a negative. So therefore positive, negative. So 5 ampere into 2 ohm it is 10 volt, and we have to keep a series of resistors which is 2 ohm. So now and here this is 3I0 and same diagram, remaining everything is same, 4 ohm, 2 ohm, 8 ohm and 10 volt. So now I want to convert this star into a delta fashion. So I am going to convert from star network to the delta network. So therefore now I am going to assume here this is Z1, the impedance is this is Z1, and this is Z2, and this is Z3. So this is Z1, Z2 and this is Z3. So I want to convert from star into a delta fashion. So therefore here the value of Z1 is equal to, which is 4 plus 8 plus 4 into 8 by 2. So 4 plus 8 plus 4 into 8, 32 by 2, which is 28 ohm. And now Z2 is equal to 4 plus 2 plus 4 into 2 by 8. So we are going to get 7 ohm. And Z3 is equal to 8 plus 2 plus 8 into 2 by 4. Then we are going to get here 14 ohm. So therefore the value of Z1 is 28 ohm and Z2 is 7 ohm and Z3 is 14 ohm. So now I am going to draw this diagram in a very simple manner. So now this diagram is going to become like this. So this diagram is now going to become like this is Z1 and this is Z2 and this is Z3. So this diagram is going to become in this. So now I am going to convert from star to delta. So star network to delta network. So by this we are going to, by using this formula star network to delta network conversion, we have figured out what is the value of Z1, Z2 and Z3. So now I am going to assume this as a reference node, and now I am going to assume this is as a some voltage V1. So I want to know what is the value of this V1. So therefore the current in this branch is I0. So it is going to upward of this voltage source. So therefore this is the I0. So now I want to know what is the value of the V1. So therefore here by using the KCL, by nodal analysis, here the current in this branch is V1 minus 10 by 8. So V1 minus 10 by 8 plus in this branches which is 3I0. So which is 3I0. So plus 3I0. In this branches V1 by Z1. Z1 is 28. So V1 by 28. And now in this branches V1 minus, so this voltage, this node voltage is 10 because it's a 10 volt source. So this is 10 volt. So therefore now V1 minus 10 by Z2 is 7. So therefore V1 minus 10 by 7 is equal to 0. So in this equation there are two unknowns, I0 and V1. So we need another equation to solve that one. So therefore now the value of I0. So the value of I0. See, I want to know what is the value of the I0. So at this node the incoming current is only I0 and the outgoing current is this current and this current. So I want to know I0 is equal to this branch current is 10 minus V1 by Z2. So 10 minus V1 by Z2 is 7. And this current in this branch is 10 by Z3. Z3 is 14 because the voltage across this branch is 10. So therefore 10 by Z3 is 10 by 14. So this is the second equation. So now we have two equations with two unknowns. So we can get V1 is equal to 30 volt and I0 is equal to minus 30 by 14. But if you see carefully here, I4 is equal to negative. So I4 and I0 in opposite directions. So therefore I4 is equal to minus I0. So we know the value of I0 which is minus 30 by 14. So if you substitute here, we are going to get 30 by 14 is equal to 2.143 ampere. So we have figured out what is the value of the I4. So now we need to find what is the value of the I1. So now you see the original network. If you see the original, so if you see this network, see we have already converted this into a practical voltage source. Now I want to convert back to the practical current source. Listen carefully, same thing, the practical current source means previous one, whatever that one, which is 2 ohm, and this is 5 ampere. So now if you see carefully, the current in this branch is I1 and the current in this branch is 5 ampere. So at this node I want to apply the KCL. So therefore nodal analysis. So sum of incoming currents is equal to sum of outgoing currents. So here at this node the incoming currents are I1 and 5. So I1 plus Y is equal to the outgoing currents are V1, which is 3I0. So 3I0. This is 3I0. And the current in this branch is outgoing current is V1 minus 0 by Z1. So V1 by Z1 is 28. And the current in this branch is V1 minus 10 by Z2. V1 minus 10 by Z2 is 7. So if you solve this one, so we know the value of I0 and we know the value of V1. So substitute them. So I0 is minus 13 by 14 and V1 is 30. So substitute there, and finally we are going to get the value of I1, which is minus 7.5 ampere. So therefore the value of I1 is minus 7.5 ampere and the value of I2 is 2.143 ampere. So now we are going to solve the 16th question. See the question here. An energy source forces a constant current of 2 ampere for 10 seconds to flow through a light bulb. If the 2.3 kilojoules is given off in the form of light and heat energy, so what is the voltage drop across the bulb? So there is a bulb here. In this bulb, the current in the bulb is 2 ampere for 10 seconds, and then the energy which is going to deliver by this bulb is 2.3 kilojoules in terms of the light and heat, means overall energy. And then we need to find what is the voltage across the bulb. So what are the four options? Option B, 115 volt is the correct solution of this question. So let's solve this numerical. So there is a light bulb. The current in the bulb is 2 ampere for 10 seconds, and in this period of 10 seconds the energy which is going to deliver by this bulb is 2.3 kilojoules in the terms of light and also in the terms of heat. Then we need to find what is the voltage drop across this bulb. So basically energy is equal to power into time. So power is equal to voltage into current into time. So here energy, which is 2.3 into 10 to the power of 3 joules, is equal to the voltage. We need to figure out the value of current is 2 ampere and the value of time is 10 seconds. So if you solve this one, V is equal to 2.3 into 10 to the power of 3 by 2 into 10, which is 20. So if you solve this one, we are going to get 115 volt. So basically here E is equal to VIT. So here the unit of the energy is joule and the unit of the voltage is volts, and the unit of the current is ampere, and the unit of the time is second. So therefore 1 joule is equal to voltage, ampere and second. So the correct solution of this question is voltage is equal to 115 volt. So now we are going to solve the 17th question. See the question here. A 3-phase motor can be regarded as a balanced star load. A 3-phase motor draws 5.6 kilowatt. Then when the line voltage is 220 volt and the line current is 18.2 ampere. So what is the power factor of the motor? So basically this is a star connected load motor, and this motor is going to absorb a power of 3-phase power of 5.6 kilowatt with a line voltage of 220 volt and the line current of 18.2 ampere. So here we need to find what is the power factor of this motor. So out of the four options, option A, which is 0.8075 is the correct solution of this question. So let's solve this numerical. So in this question there is a 3-phase motor. This motor is connected in a star fashion, and then this is a motor. So we have to, in this question they are given that the line voltage across this motor is 220 volt and the line current in this motor is 18.2 ampere, and also the amount of active power which is absorbed by this motor is 3-phase active power is 5.6 kilowatt. So we have to find what is the power factor of this motor. So basically here in a 3-phase circuit the active power drawn is, which is root 3 VL cos phi. This is for the only for the case of 3-phase. So therefore we know the value of the 3-phase power, which is 5.6 into 10 to the power of 3 is equal to into root 3 into line voltage is 220 volt and the line current is 18.2 ampere, and the cos phi is the power factor. So only the unknown parameter is cos phi. So therefore cos phi is equal to 5.6 into 10 to the power of 3 by root 3 into 220 into 18.2. So root 3 is nothing but 1.7. I am going to assume it as only 1.7. Actually the value is 1.732, but I am going to approximate to only 1.7. So after simplifying this one, we are going to get 0.8075. So this is the power factor of this motor. This is the correct solution of this question. So now we are going to solve the 18th question. See the question here. What is the input impedance of the circuit if the circuit operates at omega is equal to 50 radians per second? So this is a circuit. Here omega is equal to 50 radians per second. Then we have to find what is the overall input impedance. So out of the four options, option B is the correct solution of this question. So let's solve this numerical. So this is a circuit. We have to find what is the overall impedance. So here now I'm going to convert into reactance. So they are given only Henry and capacitor value, but we have to convert into reactance value. So therefore omega is equal to 50 radians. So now I want to know what is this reactance of this 0.2 Henry. So which is JXL. So J into XL is omega L. So J into omega is 50 and L is 0.2 Henry. So if you solve this, we are going to get 10J. And similarly, the capacitor is minus JXC. So minus J by XC is 1 by omega C. So minus J by omega is 50 and the capacitor value is 10 millifarad, which is 10 into the power of minus 3. If you solve this one, we are going to get minus 2J. And similarly, there is another capacitor of 2 millifarad. So therefore, I want to know what is the reactance. Minus JXC, which is minus J by omega C. So minus J by omega is 50 and the capacitor is 2 millifarad, which is 2 into 10 to the power of minus 3. Then we are going to get minus 10J. So we have converted this 0.2 Henry into 10J and 10 millifarad to minus 2J and 2 millifarad to minus 10J. So this is a circuit we are going to get here. This is minus 10J, 3 ohm, minus 2J, 10J and 8 ohm. So this 10J and 8 ohm are connected in series fashion and this 3 and minus 2J are connected in series fashion. Then the overall is parallel and then we have to go with the series. So therefore here 10J plus 8 parallel of 3 minus 2J and here there is a minus 10J. So therefore we are going to keep here minus 10J. So therefore this Z1, Z2 are in parallel means Z1, Z2 by Z1 plus Z2 and this is minus 10J. So therefore now what we are going to do is here after doing this simplification we are going to get 44 plus 14J by 11 plus 8J. This is minus 10J. So therefore now here I am going to do the rationalization. So therefore here 11 minus 8J by 11 minus 8J. So after doing the further simplification we are going to get 596 minus 198J by 185. This is minus 10J. So now after simplification here 596 by 185 minus J of 198 by 185 plus 10. So this 596 by 185 is nothing but 3.22 and this overall summation will going to result to 11.07. So therefore the final input impedance is equal to 3 by 3.22 minus J 11.07 is the correct solution of this question. So now we are going to solve the 19th question. See the question here. A 0 to 150 volt voltmeter has a guaranteed accuracy error of 1% of the full scale reading. The voltage measured by this instrument is 75 volt. Then what is the percentage of the limiting error? So what are the four options? Option B 2% is a correct solution of this question. So let's solve this numerical. This is the voltmeter which has a 0 to 150 volt range. So 0 to 150 volt only this voltmeter can measure. So therefore here in the question they also given the guaranteed accuracy error is equal to 1% of the full scale. So therefore here guaranteed accuracy error is nothing but it is a error. It is a error which is going to associated with each and every measurement. So if you take at any measurement, if the pointer is at any value, the error which is going to occur is a constant value which is nothing but 1% of the full scale. Means suppose I am going to measure here 70 volt. At 70 volt also the error which is going to associate is same. If you do the measurement at 90 volt also, the error associated with this 90 volt is also same. Means it is a constant error. It is independent of the pointer movement or time. It is always constant. So therefore here I want to know what is this guaranteed accuracy error. It is a error value which is 1% of the full scale value. The full scale value is 150 volts. So therefore 1 by 100 into 150. Then I am going to get here 1.5. So therefore in the question they also told that here the pointer is going to measure a 75 volt. Then what is the limiting error? Percentage of the limiting error. So basically now this pointer is going to measure a 75 volt. I have already told you the error, no matter whatever the point at the moment, so at whatever the position the pointer is, always the error will be guaranteed accuracy error. So therefore the same error we need to take here 1.5. So now we have to find what is the percentage of this one. See, this 1.5 is how much percentage of this 75. It is nothing but limiting error. So limiting error is nothing but we have to figure out what is the percentage of this 75 or of this value which we are going to measure. Suppose here 75. So therefore 75 I am going to make it as 100%. Then 1.5 is the how much percentage of this 75 we need to figure out. So 1.5 is how much percentage of this 75. So if you do the division, 75 by 1.5 is equal to 100 by x. So finally x is nothing but here 2. So therefore 2 is the correct solution. Means we can say it is 75 plus or minus 2%. So therefore this error is the now 2% of this 75. If this value is going to change, then its percentage is also going to change. So therefore the limiting error is a function of this value of the value what we are going to take here, but guaranteed accuracy error is a always constant, means the error is a constant value. No matter whatever the position of the pointer, it will be always a constant value, going to depend only upon the full scale value. Then we have to find what is this value error with respect to, so how much percentage of the actual value we have to figure out. So that is called the limiting error. So in this way we have figured out the value is 2%. So this is the last question of this lecture. See the question here. Question number 20. A 300 kVA single phase transformer is designed to have a resistance of 1.5% and the maximum efficiency occurs at a load of 173.2 kVA. So what is the efficiency when supplying full load at 0.8 power factor lagging at normal voltage and frequency? So in this question they are given a R per unit which is 1.5% and at maximum efficiency the load which we are going to connect is 173.2 kVA as the overall transformer kVA is, the rated kVA is 300 kVA. Then we have to find at 0.8 power factor and full load, we have to find what is the efficiency we need to figure out. So what are the four options? Option D, 97.6% is the correct solution of this question. So let's solve this numerical. So in the question, this is a transformer. So in this question they are given that the R per unit is equal to 1.5%. So if you want to calculate in the numerical value, so you have divided by 100, then you are going to get 0.015. So basically in a transformer, R per unit is equal to the copper loss at full load in per unit value. So therefore the copper loss at full load in per unit value is equal to R per unit. So therefore it is 0.015. So this is a per unit value, but I want to know what is the actual value. So therefore per unit is equal to actual by base value. So actual value is for copper loss at full load by the base value. The base value is we are going to take the transformer base. So always based on the transformer is the rating of the transformer is nothing but it's a base value. So therefore base power is ST is equal to 0.015. The rating of the transformer is 300 kVA. So therefore now here in place of ST I am going to substitute 300 kVA. So if you multiply this 0.015 into 300 we are going to get 4.5 kilowatt. So this is a full load copper loss which is 4.5 kilowatt in actual value, but this is the per unit value. So in order to convert the per unit to actual, we know the per unit is nothing but actual by base value. Base value is the rating of the transformer itself. So based on this we have created the copper loss at full load in actual value which is 4.5 kilowatt. So in the question they also given that at maximum efficiency the load which you are going to connect is 173.2 kVA and the rating of the transformer is 300 kVA. So basically at maximum efficiency the amount of load is nothing but it is a fraction of the ST. So the load kVA is equal to X times the ST. So this is going to tell you how much amount of fraction with respect to the total transformer kVA. So therefore SL is equal to X into ST. So I want to know what is the value of X. X is equal to SL by ST. So the load is 173.2 kVA and the transformer base is 300 kVA. So here at maximum efficiency we also know the another value of X which is X is equal to under root over iron loss by copper loss. These are the actual values. So now I am going to equate these two equations because it is X, it is also X. So 173.2 by 300 is equal to under root over Pi by copper loss at full load. Just now we have calculated which is 4.5. So substitute here 4.5. So based on this we are going to get, so only one equation with only one unknown which is iron loss. So therefore the iron loss is equal to 1.5 kilowatt. So copper loss is a variable because it is going to depend upon the load, but the iron loss is always constant which is a 1.5 kilowatt which is going to independent of the load variation. It is a summation of the hysteresis loss and also eddy current losses. So here at full load we have to find what is the efficiency of this we need to figure out. So efficiency of the transformer at any load is X into ST cos phi plus S into XT cos phi plus iron loss plus X square times the copper loss at full load into 100, percentage means 100. So here full load means X is equal to 1. ST value we know, the rating of transformer is 300 kVA and the iron losses we know which just now we have calculated which is 1.5 kilowatt and the copper loss at full load is 4.5 kilowatt and the power factor of the load which are going to connect is 0.8. So substitute all these values in this formula and finally we are going to get the efficiency of the generator is 97.6% at a full load with a iron loss of 1.5 kilowatt and the copper loss at the full load is 4.5 kilowatt and the power factor is 0.8. So with this all this data keep in this formula, finally we are going to get the efficiency of the generator in percentage value which is 97.6%. So by this lecture, we have successfully completed the 20 questions, which are the questions of the ESE Electrical Engineering Prelims paper of 2021 in a very, very detailed manner. And if you like the content of our channel, then please do like, share and subscribe our YouTube channel, and don't forget to press the bell icon button. So whenever you upload a new video, the direct notifications comes from mobile. If any improvements in our will lectures, then please do comment in the comment section. We will definitely include all those improvements in the coming lectures. Thank you so much for watching this lecture. Keep smiling, take care, and bye-bye.